Okay, students, in previous class we have discussed the theory, concept and sums of exercise 1C. Exercise 1C we completed. Now before going to topic exercise 1D, much theory is there. Let us discuss the theory. First of all, in the circles chapter, first for exercise 1D, angle between tangents is there, the formula. Angle between tangents. This is the side D. If two tangents only can be drawn from an external point to the circle. If two tangents are drawn from external point, if two tangents can be drawn from external point Px1, y1 to the circle S is equal to 0. Any circle, maybe the center is 0, 0 or center is minus g, minus f or h, k, anything. If two tangents are drawn from an external point to the circle, then angle between the tangents formula tan theta by 2 is equal to r by root s11. Of course, angle is theta. This is the notation. Angle, if you need, you should write like this: theta is equal to 2 tan inverse of r by root s11. This is the formula. Because theta by 2 is equal to tan inverse r by root s11 and theta is equal to, but the two taking cross multiplication, we can write theta is equal to 2 tan inverse r by root s11. Let us discuss about this one. Draw the circle like this. Let Px1, y1 is an external point here. Px1, y1 is external point. Put here, this is a center C. Draw like this. This is Q and this is R. Put here, this is right angle, because angle in semicircle. If full angle, here PQ and PR are tangents, the full angle is theta, full angle is QPR. If QPR is theta, if you draw a line from center C to this line, the line cuts the angle in two parts. Of course, it is nothing but angular bisector. So you can write here, this is theta by 2, these are the angle in semicircles. Now, writing description. Let Px1, y1 be an external point. Let Px1, y1 be an external point. CQ is equal to R and CR is equal to R. Since angle in semicircle is 90 degrees. Since angle in semicircle is 90 degrees, that implies angle CQP is equal to angle CRP is equal to 90 degrees. Now I am writing here, let angle CPQ. Let angle CPQ is equal to theta. Therefore, angle, not CPQ here, QPR. Angle QPR is equal to theta. So angle CPQ is equal to angle CPR is equal to theta by 2 of angle. Now using right angle triangle. Where it is right angle triangle, take here, this is a Q as right angle triangle, this is a P. Here you put theta by 2. Here you can put C. Students, we know that length of tangent, already we discussed in exercise 1b that it is root S11. So, PQ is root S11 and this is also root S11. Length of tangent formula. Length of tangent is equal to PQ, that is equal to PR. The formula root S11, proof also I said. So here you write root S11. CQ is equal to R. So in this triangle, tan theta by 2 is equal to, using opposite by adjacent, R by root S11. This is the formula. That implies this can be written as theta by 2 is equal to tan inverse R by root S11. Theta equal to tan inverse R by root S11 or angle between, therefore you can write angle between tangents. Angle between tangents is equal to theta is equal to 2 tan inverse of R by root S11. You no need to remember like this. Remember like this only. Formula angle between two tangents. The relation is tan theta by 2 is equal to R by root S11. Tan theta by 2 equal to R by root S11. You should not forget from today onwards. Depends upon tan theta by 2 is equal to R by root S11. So many sums are there in objective and IP also. Okay, now let us discuss about this one also. Again, another method I will say now. Cos theta is equal to, in some cases, cos theta is equal to, you will be giving like this formula. 1 minus tan square theta by 2 by 1 plus tan square theta by 2. 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So cos theta is equal to, you can write like this. 1 minus tan square theta by 2 means here R square by S11 by 1 plus R square by S11. So you can write here S11 minus R square by S11 plus R square. So what is S11 sir? Whatever the point he will be x1 comma y1, by substituting in the given circle you will be getting S11 and R is equal to root of G square plus F square minus C. If you ask tan sin theta, then you can write the formula 2 tan theta by 2 by 1 plus tan square theta by 2. Of course, the sin theta model is not there, cos theta model is there. Remember this formula also for objective, this is not for IPE. Now, let us go into discuss about another theorem or sums. Example 1, example 2 is there. Before going to discuss example 1, example 2, one sum is there. Page number 54, example 4 is there. Show that the area of triangle formed by two tangents through the circle and a chord of contact. Later we can discuss. Next, area of this quadrilateral we discuss. For objective I am saying. In CUQ is there, in conceptual question the question is there, area of this quadrilateral. After completion of angle between two tangents. Area of a quadrilateral. Using the same diagram. Area of a quadrilateral is equal to R root S11. Let us discuss using the same diagram. Area of a quadrilateral is nothing but area of a triangle CPQ and area of triangle CPR. Area of a quadrilateral. Area of quadrilateral PRCQ is equal to delta CPQ plus delta CPR. These are two triangles. What is the area of triangle using base into height? You observe this one, this triangle. So using half into base into height, that is equal to half into what is base here? Root S1. What is height? R. And for next circle also same concept, because radius will not change and length will not change. 1 by 2 into root S11 into R. So you can write the area of triangle is R root S11. This is a CUQ question for objective I am saying. Now let us discuss some examples. Depends upon the angle between two tangents of the circle. Example, sum is there, page number 46. Depends upon this theory. Page number 46, first and second questions are there. Example 1, 2. Example 1. Find the condition. Find the condition that the tangents drawn from exterior point G comma F to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. X square plus y square plus 2gx plus 2fy plus c equal to 0 are perpendicular to each other. Depends upon this perpendicular condition, level 1 sums are there in objective. Find the condition that the tangents drawn from a point G comma F. You put the name as G comma F. Here put the name, this is P, G comma F, this is center, this is Q, this is R. This is small r radius and draw like this, it becomes theta by 2 and this is also theta by 2. We know that here I am writing, we know that angle between the tangents, just now I proved that tan theta by 2 is equal to R by root S11. What is R here? Using the circle x square plus y square plus 2gx plus 2f plus equal to 0, R is root of g square plus f square minus c. That implies tan theta by 2. Find the condition that the tangent drawn from exterior point G comma F. Oh, perpendicular he is asking. Okay. Whenever perpendicular he is asking, then you put here theta is equal to 90. Given or condition you write. Condition means theta is equal to 90 degrees, then it becomes theta by 2 becomes it is 45. So tan 45 is equal to R by root S11. What is tan 45 value? 1. 1 is equal to R by root S11. Then you can write R square is equal to S11. Hereafter I will not say, directly I will write whenever the tangents are perpendicular, then the condition is R square is equal to S11. Condition of formula I am writing. Orthogonality or perpendicularity. Condition of orthogonality of tangents to the circle. Condition of orthogonality of tangents to the circle is, you can write as R square is equal to S11. Hereafter directly you can write R square is equal to S11. That implies, what is R square here? G square plus F square minus C. What is S11? Meaning the point, whatever the external point or internal point, anything he given, if he given G, the point, if you substitute the point in the circle, you will be getting S11 value. So substitute here as G square plus F square, G square plus F square plus 2G square plus 2F square plus C. Here G square F square got cancelled. So you can write here that 2G square plus 2F square is equal to 2C. Therefore, required condition. required condition is g square plus f square equal to c. By dividing the number 2, g square plus f square plus c given, yes, plus 2c minus not 2c. Another sum is also there in the model. G square plus f square plus c equal to 0. This one taken this side, it becomes plus 2c. Now let us discuss second question. These sums are called as locus sums. Locus sums are important for 4 marks. In circle chapter 4 marks question is there. Maximum 4 marks questions will be given in the locus sums or depends upon exercise 1D. So to get the 4 marks in circle chapter, you should concentrate the concept of exercise 1D and the sums also. If theta 1 comma theta 2 are the angles, theta 1 comma theta 2 are the angles of inclination. Theta 1 comma theta 2 are the angles of inclination of tangents through through a point P to the circle x square plus y square is equal to a square. X square plus y square is equal to a square. Find the locus of P. Find the locus of P when cot theta 1 plus cot theta 2 is equal to k. When cot theta 1 plus cot theta 2 is equal to k. Cot theta 1 plus cot theta 2 equal to k. If theta 1, theta 2 are the angles of inclination of tangents through a point P to the circle. Example P, this is tangent. P external point x1 comma y1. If it is Q and if it is R. So he is discussing with us the inclination. Inclination means it is the angle with the positive direction of x-axis. Theta 1 and theta 2. Not direct x-axis. Positive direction of x-axis, the inclination theta 1 and theta 2. So let Px1 comma y1 is an external point. Let Px1 comma y1 be an external point. We know that given circle, right here given circle, x square plus y square minus a square equal to 0. Put equation 1 here. You can write here equation of general tangent. I said that equation of general tangent or equation of tangent having slope m is y is equal to mx plus r minus r root 1 plus m square. Here at x1 comma y1 you can write as y1 is equal to mx1 plus r minus r means here a into root of 1 plus m square. That implies this mx taken this side. You can write here y minus mx1 whole square is equal to a square into 1 plus m square. You will be getting the same model for parabola, ellipse, hyperbola. These are called locus sums. Plenty of sums are there. He will be giving you as a synopsis. So simply remember as the formula this sum for object to length discussing with you. Now, by squaring both sides, already I had written directly, you can multiply like this: y1 square minus 2m x1 y1 plus m square x1 square minus a square m square is equal to 0. By taking m square as common in the term of quadratic equation of m, this is m square x1 square. Now you can write here x1 square minus m square, a square. M square taken common, it became as m square into x1 square minus a square minus m taken common within the brackets. You can write here as 2x1 comma y1 plus y1 square minus a square equal to 0. y1 square minus a square is equal to 0. Now you can write here what he is asking, the condition cot theta 1 plus cot theta 2 is equal to k. This is a quadratic equation in m. This is a QE means quadratic equation in m. So whenever the quadratic equation in m, let m1 comma m2 be the roots. Let m1 comma m2 be the roots. Now sum of roots you can write here. Sum of roots. Sum of roots means m1 plus m2. We know that the value m is equal to tan theta. So m1 you can write as tan theta 1 and m2 as tan theta 2. You can write this one as minus b by a. So 2x1 y1 by x1 square minus a square. x1 square minus a square. This is minus. Next, product of roots. Product of roots is equal to m1 into m2. Product of roots m1 into m2, that is tan theta 1 into tan theta 2. That is equal to y1 square minus a square by x1 square minus a square. Now the condition is cot theta 1 plus cot theta 2 is equal to k. Condition is cot theta 1 plus cot theta 2 is equal to k. This can be written as cot theta 1 can be written as 1 by tan theta 1 by tan theta 1 plus 1 by tan theta 2 is equal to k. Taking LCM, you can write this one as tan theta 1 plus tan theta 2 whole by tan theta 1 into tan theta 2 is equal to k. That implies, using this one, sum of roots tan theta 1 plus tan theta 2 means here 2x1 y1. 2x1 y1 by, this will be getting cancelled. You can write here y1 square minus a square is equal to k. Therefore, locus you write. What is the locus he is asking me? 2xy. 2xy is equal to k into y1 square minus a square. Locus of this point is 2xy is equal to k into y1 square minus a square. No need to write y1 square because it is only y of this locus. K into y square minus a square is equal to 2xy. Using this one, we can understand a sum. If the tangents are perpendicular, what will happen? The product of roots should be minus 1. If it is minus 1 here, you can put here y1 square minus a square by x1 square minus a square. So, putting minus 1, no time writing, next point which is required, and it is a sum also. Depends upon this sum. I want to discuss with you, if the tangents are perpendicular, then what will happen? This is simply making a positive angle, making theta 1, theta 2 inclination with the positive direction of x-axis. If the angle between tangents, if the tangents are perpendicular, now, then what becomes now? Note you write. if the tangents are perpendicular. That implies m1 into m2 is equal to minus 1. Depends upon this sum. You can write y1 square minus a square by x1 square minus a square equal to minus 1. That implies you can write y1 square minus a square is equal to minus x1 square plus a square. Therefore, minus x1 square taken this side, it becomes x1 square plus y1 square is equal to a square plus a square. Therefore, locus I am writing. Locus is x square plus y square is equal to 2a square. Locus is x square plus y square is equal to 2a square. It is called as a director circle. Before going to discuss the topic for objective, I said this sum as a note. This one he given as the sum in page number 48. Same question he given as in the another model x square plus y square is equal to a square. We should discuss this one as director circle. Let us write the definition of director circle and concept. This director circle term is not there in IPE. For objective I am handling this concept. Put side heading director circle. Director circle. The locus of points intersection of the locus of points of intersection of perpendicular tangents. The locus of points of intersection of perpendicular tangents to a circle is another circle which is concentric with a given circle is known as director circle. Is known as a director circle. Draw like this. And draw like this. Students, this is original circle. This is your external point Px1, y1. From this point, we have drawn the tangents are perpendicular. This is a circle, original circle. This is director circle. So you can understand this one as a circle is there. For the circle, two tangents are drawn. You can take external point anywhere. The locus of points of intersection of perpendicular tangents. If the tangents are perpendicular, of course, maybe you take this is a perpendicular tangent. Like that, From an external point, any external point you can take, you will be getting 2 tangent, 2 tangent like that. This is a point of intersection. The tangents intersect a point P, x1, comma y1. Like that. The locus of points of intersection of perpendicular. This is the locus. Such locus is called as director circle. The definition once again see. The locus of points of intersection of perpendicular tangents. It should be perpendicular. So theta should be 90 degrees. Perpendicular tangents to a circle. This is, this one you take. Is also another circle. This is another circle which is concentric with a given circle. Center of first circle and the second circle should be same. Whenever the center is same, then such a circle is known as director circle. He given this one as proof. Second question. What is the proof? Just I said just 5 minutes back the sum that x square plus y square is equal to 2a square. He given in another way, if the card of contact, of course. Now, don't see the question card of contact after discussing only we can do. Now, let us discuss about next concept, card of contact. What we have discussed now, equation of just angle between tangents only we discuss it. Depends upon angle between tangents, director circle also we discuss it. Now let us going to discuss about chord of contact. Chord of contact. Before going to discuss, you can write here objective formulae or objective. Formula 1. Equation of. In level 1, 15, 16, 17 questions are there. Equation of director circle of. Equation of director circle of two circles. This is called as combined equation. X square plus y square equal to a square comma x square plus y square is equal to b square is x square plus y square is equal to a square plus b square, right? We can understand this formula as x square plus y square is equal to a square is first circle and x square plus y square is equal to a square is second circle. A square plus a square we got as 2a square. If you are having separate radii for two circles, equation of director circle of two circles, combined director circle is combined, that is summation of two radii square. So it can be understood as x square plus y square is equal to a square plus b square. Next, if the center is having same, that is concentric notation. Next, second formula you write. This is I am discussing with you for level 1 15th question. Equation of, I think 15th to 22nd questions are in the same model in level 1 classwork. Equation of director circle. Equation of director circle of x minus h whole square plus y minus k whole square is equal to alpha square, comma x minus h whole square plus y minus k whole square equal to beta square is. So for the two circles, center should be same because it is concentric. X minus h whole square plus y minus k whole square is equal to alpha square plus beta square. This is the director circle. Okay. Now let us discuss about the sum. Once verify sum whenever example is there and the condition, but later we can discuss. Let us finish the theory. The theory part. For the theory part, next one, chord of contact is there. Put side heading chord of contact. Chord of contact. Just two terms indicate the definition. What is a chord? The line segment is joining any 2 points on the circle is called as chord. What is contact? That is point of contact. If a tangent drawn to circle, wherever the tangents meet the circle, the point is called as contact. So what is chord of contact? If two tangents are there for a circle, a point of contact forms for a tangent, another point of contact forms for another tangent. If we join the 2 points of contact, it becomes a chord. It is nothing but chord of contact. So first of all, we can draw the diagram, later we will write definition. This is P, x1 comma y. This is Q. This is the point of contact and this is R. That's all. Now write the definition. The chord joining the points of contact. The chord joining the points of contact of two tangents. Chord joining the points of contact of two tangents. That's all. Points of contact of two tangents drawn from an external point. Drawn from an external point to the circle S equal to 0. To the circle S equal to 0 is called as chord of contact. Is called as chord of contact. Next simple formula. You write equation of chord of contact. Equation of tangent to equation of chord of contact, equation of polar, 3 are the same. The formula is S1 equal to 0. Equation of chord of contact also, the formula simply S1 equal to 0. The S1 equal to 0 notation for the circle. Once again I am making you to remember that for the circle x square plus y square minus r square equal to 0 is xx1 notation. Xx1 plus yy1 minus r square equal to 0, and for the circle s is equal to x square plus y square. X square plus y square plus 2gx plus 2fy plus c equal to 0 is s1 notation. Xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Now he is discussing with us page number 48. Find the equation of chord of contact. Find the equation of chord of contact. Find the equation of chord of contact. Example 1, page 48. Page 48. Find the equation of chord of contact of circle or with respect to circle. X square plus y square minus 5x plus 4y minus 2 equal to 0. X square plus y square minus 5x plus 4y minus 2 is equal to 0. The notation yet 2 comma 5 here. Chord of yet 2 comma 5. So this is the point 2 comma 5. Yet 2 comma 5 the chord of contact is S1 equal to 0. Simply you write S1 equal to 0. And the notation already we mentioned here. So this is x1 comma y1. So x into 2 plus y into 5 minus this is 5 by 2. 5 by 2 into x plus 2 plus this is 2 into y plus 5 minus 2 equal to 0. You can write here by taking LCM 2 2s are 4x plus 10y 4x plus 10y minus 5x minus 10 plus 4y plus 20, those are 4, okay, minus 4 equal to 0. 4x minus 5x becomes minus x, plus 10y plus 4y, it is plus 14y, minus this is a 10, 20, 20 minus 14 is plus 6, plus 6 equal to 0. So by multiplication with minus it becomes x minus 14y minus 6 equal to 0 is the equation of card of contact. X minus 14y, this is 20 plus 6 is given. Okay, verify whether it is mistake, no problem. Now let us discuss another example, depends upon the card of contact concept and depends upon the direct circle concept. Page number 48, example 2 is there. Example 2, page 48. Page 48. If the card of contact of point P with respect to circle, if the card of contact of a point P, if the card of contact of a point P with respect to circle, x square plus y square is equal to a square. X square plus y square is equal to a square. Cut the circle at A and B. Cut the circle at A and B such that AOB is equal to 90 degrees. Such that, put like this. That indicates angle, indicates always middle letter. AOB. So O is 90 degrees. AOB is equal to 90 degrees. Then show that angle AOB is equal to 90 degrees. Then show that P lies on a circle. P lies on the circle. The circle equation also he given. So we should prove that the equation is like this. X square plus y square is equal to 2a square. Let us draw the diagram, then we can do the sum easily. He given the answer as homogenization model. We can follow other method also. If the card of contact of a point P with respect to circle, x square plus y square is equal to a square. He is discussing about card of contact. This is P. This is x1 comma y1. This is Q. This is R. This is the card of contact QR. Because the card joining the 2 points of contact of tangents is called as card of contact. QR is card of contact. If the card of contact P of a point P with respect to circle, cut the circle A and B. He put the names. I put here QR. He is saying that the name A and B. Okay, put here A and B. Such that angle AOB is equal to 90 degrees. Given circle he given as x square plus y square is equal to a square. So center C here, C is nothing but origin. He mentioned that is as O. Put here this is O. So O means 0, 0. If the card is making 90 degrees here, card is making 90 degrees, R is equal to A, then show that P lies on a circle, this one. In such case, so he is discussing about the locus of P like this. P lies on a circle, x square plus y square is equal to 2a square. We can understand this one as if a line joining from any point to the circle, if the points of intersection of two lines joining to the origin, this one, this is a line, points of intersection, this one, joined to origin, then we should follow the homogenization method. In first year exercise 4C, 6 sums are there. Depends upon that one, homogenizing equation of Cart's contact, we will be getting the answer. Because so many sums we discussed like this. The line joining, the points of intersection of line joining to origin is nothing but homogenization. It is nothing but joining to origin. So given circle 1, equation of Cart's contact, you write now. Equation of Cart's contact. Students, this is IMP 4 marks. Locus sums are IMP. Tan theta, cot theta 1 plus cot theta 2 is equal to k, we discussed k, 2kxy is equal to y1 square minus a square, it is IMP 4 marks, this is IMP 4 marks, next 2 sums are there, they are also IMP 4 marks. IMP sums for 4 marks depends upon exercise 1D only. Equation of Cart's contact. Formula S1 equal to 0 for this circle. Xx1 plus yy1 minus a square equal to 0. That implies you can write this one as xx1 plus yy1 whole by a square is equal to 1. Let this is second equation, and here you can write x square plus y square is equal to a square into 1 square. If it is x term, you should write here 1 square. If it is also x is there, you simply you no need to write. You should write only 1, there is no need to write 1 square. 1 we write now. Homogenizing 1 and 2 we get. Homogenizing 1 comma 2 we get. So x square plus y square is equal to a square into xx1 plus y by 1. X, this is y by 1. Xx1 plus y by 1 by a square total whole square. That implies you write here x square plus y square is equal to x square x1 square. X square x1 square plus y square y1 square plus 2xx1 y by 1 xx1 y by 1 whole by a square. By cross multiplication we get here a square into x square. Directly I am writing a square into x square plus a square into y square. Those term taken this side, it becomes x square x1 square minus y square y1 square minus 2xy x1 y1 equal to 0. So take common here, you get a square minus x1 square minus 2xy into x1 y1 plus take y square common here, you get a square minus y1 square equal to 0. Since whenever the line joining points of intersection of any curve or the lines, the points of intersection joining to origin, then whenever the angle is 90 degrees, then coef of x square plus coef of y square is equal to 0 in the pair of straight line ax square plus 2h square plus by square equal to 0. If the equation in the form of ax square plus 2h square plus by square plus 2x plus 2f plus equal to 0 is a pair of line, and another line lx plus my plus n equal to 0, intersecting the pair of line in this way, if we homogenize, then coef of x and coef of y and constant vanishes, then you will be getting in the form of ax square plus 2h square plus by square equal to 0, because it should pass through 0 comma 0. In that manner, coef of x square plus coef of y square equal to 0. Since I am writing here angle AOB is equal to 90 degrees. Angle AOB is equal to 90 degrees. Here you write coef of x square plus coef of y square equal to 0. That implies a square minus x1 square plus a square minus y1 square equal to 0. That implies you can write here x1 square plus y1 square is equal to 2a square. Therefore, locus of x1 comma y1 or px1 comma y1 lie in the circle is here simply locus of x1 comma y1 is x square plus y square is equal to 2a square. This is also a director circle. This is 4 marks IMP question. We can discuss this one in another method also. Depends upon this one. Another method I am saying. You know that. Don't get confused regarding equation of Carnot contact. 90 he given. So at the origin this is 90. We know that angle in semicircle is 90 whenever this is radius A, whenever this is radius A, this is 90, this is 90. Full this is quadrilateral. Sum of angles in quadrilateral equal to how many degrees? Sum of angles in quadrilateral equal to 360 degrees. This is 90, this is 90, this is 90. So this should be 90. So what became now? What happened? Angle between two tangents is 90 degrees. Whenever angle between two tangents is 90 degrees, the tangents are perpendicular. Whenever tangents are perpendicular, the condition is r square is equal to s11. R square is equal to s11 means what is r square here? A square is equal to s11 means x1 square plus y1 square minus a square. Taken up this one, using this one, taken x1 square plus y1 square minus a square is equal to a square, it becomes x square plus y square is equal to a square. That is a simple proof. Simple proof also I say. Whatever easy you follow. Of course, no need to put homogenization. Without putting homogenization, without calculating this method, I am saying shortcut method, easy method. Easily you can get 4 marks. In IP also you can write. Draw diagram like this. Second method I am writing now. Second method. Since means given you rate. Given angle AOB. Given angle AOB equal to 90 degrees. Since angle in semicircle. Angle in semicircle is equal to 90 degrees. That implies angle OAP is equal to 90 comma angle OBP. Angle OBP equal to 90. Next in quadrilateral. In quadrilateral, sum of angles. This is the main point. Sum of angles equal to 360. That implies angle APB. Angle APB is equal to, write like this, 360 minus 270 degrees. So it becomes 90 degrees. Therefore, angle between tangents is equal to 90 degrees. Angle between tangents equal to 90 degrees. Using the formula, angle between tangents equal to 90 degrees, tan theta by 2 is equal to r by root s11. Here you can write theta by 2 is equal to 45. Then you can write tan 45 equal to 1 and r is equal to root s11. By squaring both sides, r square is equal to s11. What is r square here? A square is equal to notation of s11 regarding this circle x square plus y square minus a square. Therefore, x1 square plus y1 square. X1 square plus y1 square is equal to 2a square. Is equal to 2a square. Therefore, Px1 comma y1 lies on the circle. Px1 comma y1 lies on the circle x square plus y square is equal to 2a square. X square plus y square is equal to 2a square. Okay students, so pole-polar concept is there, very important concept. Let us going to discuss in next class.